Okay, here we go. So today what we're gonna do is I just moved it. I think it's okay. We're gonna go through the different forms of the quadratic functions, and you're gonna be able to convert from one form to the other. And why you wanna be able to do that is because each form gives us something really nice, right? Each form has something that we need in order to graph completely the quadratic function, okay? So, let's talk about each of these. This one is in x-intercept form, and I'm going to abbreviate it IF for intercept form. What's nice about x-intercept form? What two things do you get from x-intercept form? What two things do you get from x-intercept form? You get
x-intercepts.
the x-intercepts, which in this case would be 4, 0, and negative 2, 0. It's the opposite of these. And you also get that a value. If it's positive, it's going up. If it's negative, it's going down, right? This is an example of transformation form. What's so good about transformation form? We get two things from this. We get the axis of symmetry, which is x equals 2. We get the vertex, 2, negative 47. And the a value if it's up or down. Positive, it's up, negative, down. The third one is polynomial form. What's so good about polynomial form? There's two things that's good with this form. If the a value is positive, it's up, and this number right here is the what? What's this number right here?
C.
It's the y-intercept. So between the three of those are the major components of a quadratic function. Your job is to be able to go from one form to the other so that you can get all of those components. Okay, that's what we're going to do. So, let's start with the first example. We have This is x-intercept form. Again, why do we like x-intercept form? Because we have the x-intercepts, which are 4 and negative 2 for this problem. Why would we want to go to polynomial form? So we can get the y-intercept. Now there's two ways to get the y-intercept. You could mathematically plug a 0 in for x and solve it, or what you can do is stretch this out. How would you stretch this problem out? It should be fairly easy. How would you stretch this problem out to write it in polynomial form? In other words, I want to get it to look like this. This is polynomial form. How do I turn x-intercept form to polynomial form? What do you think you do? FOIL. Now you could do one of two things. You have options. You can FOIL these two, which that's what most people would do. They would FOIL these two, first, outer, inner, last, and then distribute the negative 2. Or what you could do is do negative 2x plus 8 and then FOIL. It's up to you. Let's FOIL this. What do you get when you FOIL x minus 4 times x plus 2? You should be able to do that in your head. You get x squared, and the middle two terms give you negative 2x, and then the outers are negative 8. Everyone cool with that? And now what do you do with that negative 2? You're going to distribute. So, one thing you're going to want to do is make sure you have f of x on one side, your equal to sign. I don't want to see an expression. I want to see a y and an x. And x has to be squared. Don't forget that. These are common mistakes. Some people forget to put squared here. So now, What was the purpose of going from x-intercept form to polynomial form? What do we now know? We know the y-intercept. So for this problem, we know the x-intercepts and we know the y-intercept. What was the other way of figuring out the y-intercept? What did I say you could do? You set, another way is set x equal to 0, and you can do that in your head. What is 0 minus 4? Negative 4. What's 0 plus 2? 2. So what's negative 2 times negative 4 times 2? Oh, it's 16. So there you go. There's another way you could have done that. Okay? How do you go from transformation form to polynomial form? So we want to stretch this out. I just need to make sure you all know how to correctly do this problem. Stretch it out. How do you stretch this one out? Can I distribute the 3? Yes or no?
No.
No. You have to FOIL the x minus 2 squared. So this goes, you have to do this piece first, right here. How do you square that quantity? You square the first term, you multiply these two together times 2, and you square the last term. Now what you're going to do is multiply the 3 by all these 3 items, so 3x squared minus 12x plus 12, and now add negative 47, and your final answer is 3x squared minus 12x minus 35. And don't forget f of x. So we went from knowing the axis of symmetry, the vertex, up or down, and now we can add our y-intercept. What would be another way to find the y-intercept? If you didn't want to do this, what could you do to find the y-intercept? Again, you set x equal to 0. So if I put a 0 here, what's 0 minus 2? Negative 2. What's negative 2 squared? 4. What's 4 times 3? 12. And what's 12 minus 47? 12 minus 47 is negative 35. So you could have done it that way. So for homework, you're going to do these numbered problems, 1, 2, and 3. I want you to go from either x-intercept or transformation form to polynomial form. I want to make sure you can all do that. Okay. The next thing you're going to be able to do. How do you go from polynomial form to transformation form? And why do we want to be able to write these in transformation form? What does transformation form give us? It gives us the axis of symmetry and the vertex, which are it's the max and the mins of the problems. So I'm going to show you 2 different ways to do this. Okay, one way is finding what we did yesterday, the axis of symmetry. Do you remember the formula for the axis of symmetry? It's x equals negative b over 2a. Remember that formula? Okay, so what is the b value? It's negative 16, so it's 16 over 2 times 2, which is 16 over 4, which is 4. How do you find the y value, to find the vertex? You're going to plug 4 into this equation. So 2 times 4 squared minus 16 times 4 plus 12. What do you get when you find the y value? Give me a second. I get negative 20. Did you get negative 20? So 4 and negative 20 is your vertex. So find the vertex. It's 4, negative 20. How will you go from polynomial form, which gives us the y-intercept, to now we have the vertex? How are you going to plug this into the equation? Well, what does the equation look like? It's like this. That's it right there. That's the form. That's your recipe. So I need the a value, first of all. What is the a value in this problem? 2. So you're going to write f of x equals 2, parenthesis, here's your axis of symmetry, x minus 4 squared, and then minus 20. So we just went from polynomial form to vertex form. Okay? Now there's another way to go from polynomial form to vertex form, and that's by completing the square. That's this way, completing the square. I'm going to show you how to complete the square, and we're going to do the next problem that way. How do you complete the square? These are your steps to complete the square. You're going to turn this into a perfect square trinomial. Step 1, see this 12? You're just going to slide. We're not going to touch this side. The f of x is going to be untouched, this left side. So step 1 is we are going to slide 12 over. Just leave some space. You aren't going to do anything to this 12. Nothing. It stays like that. Now, in order to complete the square, you have to have a 1 for a leading coefficient. Right now there's a 2. So you're going to yank the 2 out of these two. You're only going to mess around with these two. So pull a 2 out of these two. Divide these both by 2. And you get this. Do you agree? Does everybody agree? I pulled a 2 out. Now to complete the square, you take half of this middle term. What's half of negative 8? Half of negative 8. Negative 4. And you square that number. You get 16. Now because I put parentheses here, I really added 32 right here. I added 32, not 16. So if I add 32, what should I do if I work on the same side? I'm adding 32, so I'm going to take 32 away. Why am I taking 32 away? Because 32 minus 32 is 0. So that means I did nothing to this side, which is good, because I'm not going to do anything to the other side. Does that make sense? If I added 32 to this side, then I could do that, but why do I want to mess with that? I want to leave that as f of x. So I added 32 here. I'm going to take 32 away. Now, what does this become right here? This is a perfect square trinomial. It factors to be x minus 4 quantity squared. That's what that factors to be. X minus 4 quantity squared. And now just clean up everything else. Bring the 2 down, that's your a value. And what is 12 minus 32? Negative 20. Now, is this the same answer that we got doing it the other way? Do they match? They sure do. This and this matches. So you have 2 options. You can find the axis of symmetry, negative b over 2a, and then plug that in. People seem to make math errors this way. And so that one has its faults. And then this one, people struggle with completing square. Now, I want to practice completing the square with this one. See if you can do it on your own. Can someone help me out here? What should I first do? Say it. Bring the 14 over, just move it over. Good job. Just don't touch it. I see a lot of you guys dividing this by 2. No, don't do that. Now, take 2 out of what? Just these 2. Now we complete the square. Half of -6 is -3, square it, you get 9. Do we subtract 9 here? What do we do here? We added 18, we're gonna take 18 away. So you get 2x minus 3, you're gonna factor this now, minus 4. So now we have, not only do we know our y-intercept, but we know our axis of symmetry and we know our vertex, 3, -4. So for 4, 5, and 6, 4, 5, and 6, I want you to go from polynomial form to transformation form, whichever way you want. Do you want to complete the square, or do you want to find axis of symmetry and vertex? We'll go to the next 3 problems. These 3 are in polynomial form. We could go from polynomial form to vertex form. We just did it. Can we go from polynomial form to x-intercept form? Yes. We learned in chapter 2, 2.2, how to get the x-intercepts. How do you get the x-intercepts? What you do is you set y equal to 0 and you solve. Now, how are you going to solve these? Well, there's 3 ways. 1, if it's factorable, factor it. If it's not factorable, what do you have to do? You either complete the square, or you use the quadratic formula. Those are your 3 choices. Okay, so you want to first find your zeros. And then how are you going to write the x-intercept form? The x-intercept form looks like this. F of x, write this down, equals a, and then x minus s, and x minus t. We'll use s and t as our x-intercepts. It's always the opposite. S and t are your x-intercepts. You need the a value and you need the 2 x-intercepts. Sometimes there's only 1, so it might be s minus t squared. Okay, so what are your, can you factor this one? Yep, you can. You get x plus 5 and x minus 1. So what are your x-intercepts? -5 and 1. So in this case, it's easy. It's going to be x minus -5 and x minus 1, which is exactly what you have here. Don't forget your y, and don't forget the a value. The a value happens to be 1. So for the, if it's factorable, and the x's are 1x, then actually this is your answer. So x plus 5 times x minus 1. Okay, so I wanted to do an easy one to show you that sometimes they're that simple. But look at this one. This one is also factorable. I want to show you what this answer looks like. How do you factor this? This was one like that was on your chapter 2 test. Well, you can guess and check. So what times what is 3x squared? 3x times x. Now we need the middle term to be -14x. This is factorable. If you put a -5 here and a +1 here, you can find your 2 x-intercepts. Now leaving it like this is not the x-intercept form that I want. That's not the right form. That's why I did what I did here to show you what you're going to do. I need your 2 x-intercepts. What are they? X is equal to, what are your 2 x-intercepts?
-1/3.
-1/3, and what else? And 5, right? Okay, so this is what x-intercept's gonna look like to you guys. It's gonna be f of x. What's the a value? What's the a value? 3. You're gonna put a 3 outside, and then you're gonna write x minus negative 1/3, we'll clean it up, and x minus 5. Or, better yet, x plus 1/3 and x minus 5. That is what x-intercept form will look like.
Well, why is it f of x on the bottom almost y equals?
The same thing, f of x means y.
Oh.
Same thing. They're interchangeable. F of x and y are the same thing. So if I give you one, let's say something factored out to be 2x minus 1, I'm just gonna make this up, and 5x plus 4. Okay, so, let's say you factored something. Do you know to write this in x-intercept form? It's not it's factor, but it's not an x-intercept form. You guys know how to do this now. What are your two x-intercepts? What are they? 1/2 and negative 4/5. Okay, so how are you gonna write this? This is what I need. I need a. You guys know what the a is? I didn't give it to you. What's the a value? How did you have to do something in your head? It's 10, good job. You have to FOIL this times this, it's 10. So this is gonna be a 10. What else? X minus 1/2 and x plus 4/5. That's what x, that would probably be the newest thing for you. You're not used to seeing it like this, right? Is everyone okay with this? All right. Now, here's an interesting one, and I'm sorry, write small because I didn't leave a lot of room. What happens when you get answers that are not integers or rational numbers, like this one? This isn't these are irrational zeros right here, but they're still real. Okay, so this one's not factorable. I don't know what times what is -3 but adds to be -8, and the a value is 1. So what other two ways do we need in order to solve them if they're not factorable? We have to do one of these two methods. I don't care which one you do. I think for this one, the easiest method is completing the square. So if we plug a 0 in here, x squared minus 8x minus 3 equals 0. Why do I choose the complete the square? Because this is an even number. When the middle term is even, it's complete the square for me, because it's easy to do. Watch how easy it is. Add 3 to the other side. Take half of -8 and square it. So -4 squared is 16. Now this one you're going to add 16 to both sides, because you're working on both sides. Think of a balance. If you added a weight on one side, you have to add a weight on the other to balance it off. So, versus when you write something in transformation form. So factor x minus 4 squared equals 19. Take the square root of both sides, and you get x minus 4 equals plus or minus root 19, and then add 4. X is equal to 4 plus or minus root 19. These are your two x-intercepts. It's 4 plus root 19 and 4 minus root 19. So how will you write this answer? It's going to look ugly. So you're going to write f of x, write small, equals. The a value is 1, so don't worry about writing. You don't have to put a 1 there. It'll be x minus 4 plus root 19, parenthesis, parenthesis, and then x minus 4 minus root 19. That's why I said I was going to run out of room. So it looks like this. I'll write it again. F of x equals 1, the a value is 1, you don't need to write that. It's x minus 4 plus root 19 and x minus 4 minus. And you can just leave this answer like that. That's how you write it in x-intercept form. Now, what if, I'm going to change this problem around for a second. What if I had x squared plus 8x minus 3? And I asked you to write this in x-intercept form. Watch this one. If I asked you to write this one in x-intercept form, add 3. Actually, I'm going to change this to plus 20. Make that plus 20. So we're going to subtract 20. So take half of 8, which is 4, and square. You're going to add 16 to both sides. How do you write this in x-intercept form? How do you write this in x-intercept form? How do you write this in x-intercept form? Whoops, that's squared. You can't. Why can't you? Because there are no x-intercepts. This is a strange case. So I'm going to show you really quick why there are no x-intercepts. So if you were to graph this, x squared plus 8x and then plus 20, you will see that the graph, can you guys see that? There are no x-intercepts. I proved it mathematically. Why are there no x-intercepts? Because underneath the radical is a negative number. You can't take the square root of a negative number. So sometimes, this is the only weird one, sometimes if there are no x-intercepts, then you can't do that form. You can't write it in something that it doesn't have. But every other one you can do. Every quadratic formula has a vertex, so you can do transformation, and it has a y-intercept, so you can do it in polynomial form. But there's a select few that do not have x-intercepts, so you can't write them all in x-intercept form. Okay? So you might find one of these in that category, these 3 homework problems. Okay, the last one that I'm going to go over with you is how do you go from x-intercept form to transformation form? There's actually 3 ways. I wrote 2, but I'm going to show you 3. I'm going to show you 3 ways. Okay, does anyone think they can figure out how would you go from x-intercept form, which has the 2 x-intercepts, to transformation? There is a way you can go right into it. Right into it. Let me show you that way first. If I were to plot these 2 x-intercepts, where are the 2 x-intercepts? Can anyone tell me where the 2 x-intercepts are? 4 and -2. Okay? And this thing's going to be going upside down. It's going to be like something like this. So does anyone think they know, you want to go to transformation form without doing any math, can you figure out the axis of symmetry? 1, how'd you get that? It's halfway, very good. So x equals 1 is your axis of symmetry. And what important point lies on that line? The vertex. How would you find the vertex? What would you do with this 1? You would plug it in right here and here. So what would be the y value? If you plugged 1 here and 1 here, you get -2, and then you get 1 minus 4, which is -3, and 1 plus 2 is 3. Help me out here. -9, so it's 18. So your vertex is 118, correct? We figured it out just by sketching a little graph. So can you go from x-intercept form to transformation for me right now? How do you go to transformation right now? What do I need? F of x, or y, equals, what do I need first? The a value. What's the a value? -2. I need the axis of symmetry, x minus 1 squared, and plus 18. So did everyone understand what I did? I went from my two x-intercepts, I divided those two numbers in half, added them up, divide by 2. You get your axis of symmetry, which is 1, and then you plug 1 in to find the y value. That's one way. The other ways would be, the other two ways would be, I'd have to FOIL this. Turn this into polynomial form, which I would factor the x minus 4, x plus 2, and then distribute the -2. So f of x would be, if I do it in steps. It'd be x squared minus 2x minus 8, distribute the -2, and then from here, how would I find the vertex? Well, I could complete the square, or I could do the x equals -b over 2a. So if I do -b over 2a, I'm going to get 4 over -4, which is 1. And when I plug 1 in here, I'm going to get that the y value is 18, and I do it that way. So y is equal to -2 times x minus 1 squared plus 18. And then the other way would be to complete the square. How do you complete the square on this? You want to slide 16 over. So -2x squared plus 4x, bring 16 over here. Divide both of these by -2. Half of that, square it, you get 1. You added -2, so you're going to add +2 here. You do the opposite, factor it, and you're done. Just make sure you put a y in front, or an f of x. So, how do you go from x-intercept form to either polynomial form or transformation form? Well, if you want to do it this way, I don't care. You just hit, now be careful. Sometimes you might have to get a number like a half for axis of symmetry. That happens. Or you could factor that out and use the two methods that we did in, I think it was the second example. Okay, is it starting to connect? Hopefully it is. Now, the last page are 3 graphs. This is what your test is going to look like, the very last page of your test. There's going to be 3 equations. Each one is in a different form. So that one's in transformation form. So what I would do is I would take transformation form and I would fill in everything I know about it. And then I would convert it to polynomial form, and then I would find the x-intercepts. I'm going to let you see how well you do on these. You all should be able to find everything that's involved in these. You have enough information that we've worked with over the last month to be able to solve these completely without using a graphing calculator. Okay? So that's you have 14 problems for homework, and you have plenty of time. You might be able to get it all done right now. Let me know if you guys need help.